Download this code from codegive.com, link in the description below. Reducing latency in applications, especially those that rely on remote procedure calls, RPCs, is crucial for improving user experience and performance. One popular way to achieve this is by using protocol buffers, protobufs, for efficient serialization of data. In this tutorial, we will explore how to reduce latency by 60% using protobufs in a React application with a node.js backend. Overview of protobufs. Protocol buffers, protobufs, are a language-agnostic binary serialization format developed by Google. They are efficient in terms of size and speed compared to JSON or XML, which helps in reducing latency during data transmission. Prerequisites. 1. Node.js, make sure you have node.js installed. 2. React, basic knowledge of React. 3. Protobuf compiler, install protoc, the protobuf compiler. 4. npm, familiarity with npm for package management. Steps to reduce latency using protobufs. 1. Define protobuf schema. 2. Generate protobuf classes. 3. Set up node.js server. 4. Create React frontend. 5. Measure latency. Step 1. Define protobuf schema. Create a file named message.proto to define your protobuf schema. This file will describe the messages you want to serialize. Protobuf. Syntax equals proto3. Message user. int32 id equals 1. String name equals 2. String email equals 3. Message user response. Repeated users equals 1. Step 2, generate protobuf classes. Use the protobuf compiler to generate classes for the defined schema. Run the following command in your terminal. Bash. protoc.js_out equals import_style equals common JS binary. Message.proto. This will generate a message_pb.js file containing the necessary classes. Step 3, set up node.js server. Create a simple node.js server that uses protobuf for serialization. 1. Initialize a node.js project. Bash. mkdir protobuf example. cd protobuf example. npm init y. npm install express body parser Google protobuf. 2. Create a server file, server.js. JavaScript. Const express equals require, express. Const body parser equals require, body parser. Const fs equals require, fs. Const protobuf equals require, Google protobuf. Const messages equals require, /message_pb. Const app equals express. App use, body parser.raw, type, application/octet stream. App post, /API/users, req, res, equals. Const user response equals messages.userResponse.deserialize binary, req body. Const users list equals userResponse.getUsersList. / simulate processing and respond with the same data. Const response equals new messages.userResponse. Response.set users list, users list. Res.send, response.serialize binary. Const port equals 5000. App listen, port, equals. Console.log, server is running on http://localhost $port. Step 4, create React frontend. 1. Set up React application. Bash. npx create React app protobuf React. cd protobuf React. npm install Google protobuf. 2. Create a simple React component, app.js. JavaScript. Import React, use effect, uses state from React. Import user, user response from /message_pb. Function app. Const users, set users equals uses state. Const fetch users equals async, equals. Const user1 equals new user. User1.set id, 1. User1.set name, John Doe. User1.set email, john.doe@example.com. Const user response equals new user response. User response.set users list, user1. Const binary data equals user response.serialize binary. Const response equals await fetch, http://localhost 5000/API/users. Method, post. Headers. Content type, application/octet stream. Body, binary data. Const response data equals await response.array buffer. Const user response deserialized equals user response.deserialize binary, new uint8 array, response data. Set users, user response deserialized.get users list. Use effect, equals. Fetch users. Return. div. h1 user list /h1. ul. Users.map, user, equals. Leaky equals user.getID, user.getName, user.getEmail, /lee. /ul. /div. Export default app. Step 5, measure latency. To measure the reduction in latency, you can use tools such as Postman or browser developer tools to analyze the time taken for requests. Compare the performance between using JSON versus Protobuf. Conclusion. Using protocol buffers can significantly reduce the size of the payload and speed up serialization/deserialization processes, which leads to lower latency in data transmission. In this example, we defined a simple user schema, set up a node.js server, and created a React frontend that communicates with the server using protobufs. You can expand on this example by adding more complex schemas and handling various types of data to further optimize your application's performance. Always remember to profile and measure the impact of optimizations in a real-world scenario.